Welcome to General Chemistry Mini Lecture Series, Lecture 7. So today we are going to talk about problem solving and dimensional analysis. You see, in chemistry, in order to have a problem solved, so it is very often we need to convert one unit of measurement to another. For example, we need to convert from the number of molecules to the mass of molecules, from gallons of milk to liters of milk, and so on and so forth. In dimensional analysis, we are going to take the advantage of relationship between two units, and we will use those relationships as conversion factors. When you use conversion factors, you really need to remember this rule. Always place the unit of converting from, or the unit, the measurement you know, or that is given, as the denominator, and the unit of converting to, or the one you need to find, or here I call that desired unit, as the numerator, so that the given unit can be cancelled. That's very important. Let's take this example. The relationship between grams and milligrams. 1 gram equals 1,000 milligrams. Using this relationship, two conversion factors can be given. Either 1 gram on the bottom equivalent to 1,000 milligrams on top, or milligram on bottom, 1 gram on top. You see, both conversion factors are based on this relationship, depending on what do you need. If you are asked to convert from grams to milligrams, you use this conversion factor, grams on bottom. You see here. And if you are asked to convert from milligrams to grams, the reverse process here, then you need to place milligrams in the bottom and converting to 2 grams, the gram on top. Okay, so two conversion factors can be written for every relationship. And we can have examples here. So let's work on this. 5.255 grams. And we are converting from grams. So I'm not sure you could see this red dot. So we are converting from grams, and we put that unit on bottom, 1 gram. Converting to milligrams, we'll place that on top, 1,000 milligrams. Okay, this way you see grams and grams can be cancelled. That's why we ask you to place the unit of converting from as the denominator. Okay, so therefore we have the answer here, 5,255, and then you see the remaining unit here is milligrams. You just copy that. Okay. Now another example, 278 milligrams. We want to know how many grams is that. So we'll start with 278 milligrams. And this time we have to use this conversion factor. All right, we have to use this one. We are converting from milligrams. I will place milligrams on bottom, 1,000 milligrams. So 1,000 milligrams to grams. 1,000 milligrams is equivalent to 1 gram. And now, you see, we can cancel milligrams. And now, grams should be the remaining unit for the answer, and that should be 0.278 grams. Okay, let's look at another relationship. 1 inch equals 2.54 centimeter. Again, two conversion factors can be written based on that relationship. One is an inch on bottom, another one is centimeter on bottom, depending on what you need to do. Let's work on the first one. 12.6 inches equals how many centimeters? Okay, so 12.6 inches, we are converting from inches, I will put inches on bottom, to centimeters, 2.54 centimeter. Again, inches are cancelled, so the answer is 32.0 centimeter. So that's for this question. Then let's work on another one. 56.8 centimeters is equivalent to how many inches? 56.8 centimeters. This time we are converting from centimeter, put the centimeter on bottom and put the inch on top, and then write down the relationship. Centimeters are cancelled, so now that should give 22.4 inch. Okay, sometime you need to conduct more than one step dimensional analysis. As many as n steps, and you are going to use related units. Okay, so from given unit, your goal is to obtain or to find out the value for the desired unit, and in between, you may have as many as 3, 5 related units. Okay, so that's what this general equation means. Let's take a look at this problem so that we can digest this equation. So how to use this equation? Okay, the average density of cow milk is 1.031 gram per milliliter at 20 degrees Celsius. What is the mass in kilograms of 3.785 liters cow milk at 20 degrees Celsius? Okay, we have 20 degrees Celsius appearing twice in this question, but they are really not involved in the mathematical calculation. So they are here because the density is a function of temperature. So therefore, we can use the same density to do the calculations because the temperature is at 20 degrees Celsius. That's about room temperature. So how do we approach this problem? First, we will find out what are the related units. What is the given unit? The given unit is liter. First, we need to convert from liter to milliliters because the density used the milliliter here. And then from this milliliter to the other unit in the density, grams. And now, since grams is not the unit for what is asked is kilograms, we need to convert one more time, kilograms. So now you see the given unit is a liter, related unit 1 is milliliter, related unit 2 is gram, and the desired unit is kilogram. Now we are ready to work on this question. We start with what is given. What is given is 3.785 liters. And first, we need to convert from liter to milliliters. Converting from liter, put that on bottom, converting to milliliters, place that on top. But we are not done yet. It's only the first step. The second step is from milliliter to grams using this density. Converting from milliliter to grams, copy the density here, grams. Again, gram is not the desired unit. The desired unit is kilograms. So we need to convert that one more time from grams, place that on bottom, kilograms, place that on top. 1 kilogram is 1,000 grams. Now let's take a look. Liters are gone. Milliliters are gone. Grams are gone. And we just have kilograms. Take a look before you use your calculator. We have 10 to the third on top, also 10 to the third on bottom. That would give us 1. We can cancel this 2 as well. And then we have 1, 1, 2 ones on the bottom. Anything divided by 1 is still that thing. And we have 1 on top. Anything multiplied by 1 is also that thing. So therefore, we can ignore those 3 as well. The only mathematical operation we need to do is 3.75, use your calculator, times 1.031, just one calculator operation. And that should give you actually 3.902.335. You may even have more digits. Okay, but now, obviously, we cannot write down all of these digits based on the rules for significant digits. This is multiplication, and we have, you see how many sig figs in the measurement? That's 4 sig figs. So therefore, we need to keep 4 sig figs. In order to do that, I will underline the last digit, which is the digit 2 right here. So then the digit next to 2, that's 3, which is less than 5. So I can just simply drop that. Therefore, the answer should be 3.902 kilograms. You may ask me, Professor Frank, wait a second. What happened with the sig figs here, 1, and the sig figs here, 1? Okay, what are those? Those are definitions. 1 liter equals 1,000 milliliters. Definition. 1 kilogram equals 1,000 grams. That's definition. When you deal with significant figures or digits, definitions, they do not apply. So therefore, 4 sig figs. That's the solution for this question. And now let's take a look at those end of lecture quizzes. We will work on number 1 here, then you will work on the remaining ones and many more from other sources. Okay? Question number 1. How many quarts are there in 90 milliliters? And we have the relationship here. So how do we do it? We start with what we know. 90 milliliters. So first we need to convert from milliliter to liter, because you see in the relationship liter is there. That's a related unit. 1 liter is 1,000 milliliter. Okay. Now we need to convert from liter to quarts and use the relationship given right here, 1.057. So now you can see milliliters are gone, liters are gone. So therefore, the unit for the result or for the answer should be in quart. And your calculator should give you 0.09513 quarts. And that's 4 sig figs. When 4 sig figs, you can see the measurement that is given in milliliters. That's 4 sig figs. All right, there is a decimal point, so therefore the trailing zeros are significant. Okay, this is lecture 7, and I will see you guys in lecture 8.